The production of solar energy compared to other energy sources involves differences in how electricity is generated, the efficiency of each method, capacity factors, and the total global output. Here's a detailed comparison. 1. Solar energy production. How it works. Solar photovoltaic (PV) panels convert sunlight directly into electricity using semiconductor materials like silicon. Solar thermal systems concentrate sunlight to heat a fluid, which is then used to generate steam and drive a turbine. Efficiency. Solar PV panels generally convert 15–25% of sunlight into electricity. Advances in solar technology have improved efficiency, but it's still lower than many other energy sources. Capacity factor. The capacity factor for solar energy, the actual energy produced as a percentage of maximum possible output, is relatively low, typically between 15 to 30%. This is because solar panels can only produce electricity during daylight hours and are affected by weather conditions. Global output. Solar energy has been growing rapidly, reaching around 1,200 gigawatts of installed capacity globally by 2023. It contributes a significant and growing share of global electricity production, but it still lags behind fossil fuels and hydropower in total output. 2. Wind energy production. How it works. Wind turbines convert kinetic energy from wind into electricity through the movement of blades, which turn a generator. Efficiency. Modern wind turbines have efficiencies between 30 to 45%, making them more efficient than solar panels in converting available energy into electricity. Capacity factor. Wind has a capacity factor ranging from 25 to 50%, depending on location and wind conditions. Offshore wind farms often have higher capacity factors due to more consistent wind. Global output. By 2023, global wind power capacity reached about 900 gigawatts. It is a major source of renewable energy in many countries and is often paired with solar for a more balanced renewable energy mix. 3. Hydropower production. How it works. Hydropower plants use flowing or falling water to turn turbines that generate electricity. This can be done through large dams or smaller run-of-river setups. Efficiency. Hydropower is highly efficient, with conversion rates of 80 to 90%. It is one of the most efficient methods for electricity production. Capacity factor. Hydropower's capacity factor is relatively high, often between 30 to 60%, because it can generate electricity continuously if water flow is stable. Global output. Hydropower is the largest source of renewable energy, with over 1,300 gigawatts of installed capacity globally. It remains a key part of the energy mix in countries with suitable water resources. 4. Fossil fuel-based energy production. How it works. Coal, natural gas, and oil are burned to produce steam, which drives turbines to generate electricity. Efficiency. Natural gas plants are the most efficient fossil fuel plants, with conversion efficiencies of up to 60% in combined cycle setups. Coal plants have lower efficiencies, typically around 33 to 40%. Capacity factor. Fossil fuel plants have high capacity factors, typically between 60 to 90%, as they can operate continuously and are not dependent on external conditions like sunlight or wind. Global output. Fossil fuels still dominate global electricity production, providing around 60–70% of the world's electricity. However, the shift towards renewables is reducing their share gradually. 5. Nuclear energy production. How it works. Nuclear power plants use nuclear fission reactions to produce heat, which is used to generate steam that drives turbines. Efficiency. Nuclear plants have efficiencies between 33 to 37%. While the thermal conversion process is similar to fossil fuel plants, nuclear plants don't emit greenhouse gases during operation. Capacity factor. Nuclear plants have a high capacity factor, often around 85 to 95%, because they can run continuously for long periods before needing refueling. Global output. Nuclear energy contributes about 10% of global electricity production, with over 400 reactors worldwide, producing more than 380 gigawatts of capacity. It provides a stable, low-carbon energy source but faces challenges with waste management and public perception. 6. Biomass and bioenergy production. How it works. Biomass plants burn organic materials like wood, crop residues, or waste to produce steam and generate electricity. Some systems use biogas produced from organic waste. Efficiency. The efficiency of biomass power plants is typically 20 to 35%. However, the overall carbon footprint depends on how sustainably the biomass is sourced. Capacity factor. Biomass power plants have capacity factors around 60 to 85%, similar to fossil fuels, as they can operate continuously if a steady fuel supply is available. Global output. Biomass contributes a smaller share to the global energy mix, around 100 gigawatts of installed capacity, but is an important energy source in regions with abundant organic waste. Comparison summary. Overall analysis. Solar and wind, best suited for decarbonization but require storage solutions due to their variable nature. Hydropower, excellent for consistent power generation but limited by geography and environmental considerations. Fossil fuels, provide stable and scalable energy but come with high environmental costs. Nuclear, offers low carbon, reliable power but faces challenges with waste management and high initial investment. Biomass, can be carbon neutral with sustainable practices but is less scalable compared to other renewables. Each energy source plays a unique role in the global energy landscape, and many regions are adopting a mix of these technologies to balance costs, reliability, and sustainability. Solar energy, with its rapidly declining costs, has become a leading option in this transition, particularly when paired with energy storage technologies like batteries.